Hey guys, and welcome back to the Sentinel 400 TV restoration project. When we last left off, we got this kind of working, so picking up right where we left off, and still struggling. We get really bad interference on the screen. So we get lines, ripples, distortions, which is usually caused by the shield in the high voltage box being missing or compromised. Well, this is firmly screwed down. I have the shield installed over the CRT. Actually, the shield really didn't make much difference at all. If I take this off, it gets completely swamped out with interference. So putting this on helped considerably, but there's still a lot. And it's really hard to get a stable sync on the picture. And the sound is garbled. I've tried playing around with tweaking the local oscillator adjustment. It helped a little bit, but not that much, so gotta figure out what's going on. Now, one possibility that occurred to me is my kind of crude hookup here. These leads could be picking up some noise, possibly. However, I think even if I feed in no signal, we could play around with that, but it seemed like even with no signal, I was still getting interference coming in. In other words, is it coming in through the antenna, or is it radiating inside here somewhere? I'm also trying to sniff for ozone. If you recall, there was a lot of black goo smeared all over the high voltage resistors and some of the high voltage components. I put some Corona dope on my rebuilt high voltage filter, but I didn't put it on the resistors down below, because if there's a little bit of arcing Corona discharge somewhere, that can definitely cause a lot of interference. But I'm not really smelling any. I kind of smell hot electronics, but that's about it. So, I don't know. One thing I can try doing is adding some additional filtering to the high voltage. I'll tack a 1000 picofarad 6000 volt cap underneath this chassis. That's something simple enough to try. So when I rebuilt that high voltage filter, I didn't have exactly the right values. I think they had 560s originally. I put in 470s or something like that. So maybe. Moving on to troubleshooting, I was a little bit puzzled at first as to how the heck can you work on this set with it powered up and get access to the underside of the chassis when you have this short little cable between the chassis. It turns out if you put them on their side back to back, you can connect them up and have it powered up. It's a little awkward having the controls here and the screen way over there, but it does work. I do have it powered up. What I'm trying now is to isolate. Is a problem there? Is the problem there? So we have really bad interference on the screen. I went over this chassis, put all the screws in the shield, made sure it was secure, made sure the shield on the CRT is seated properly, tightened down, went over my joints underneath in the high voltage area, sniffed around for any Corona. I put some Corona dope on the high voltage filter inside here. That's where we're at. So what I'm doing to try to isolate this is, so I'm thinking, well, the problem could be, is it coming through the antenna? Is it a problem in the IF and the detector? So what I'm doing is I'm injecting a video signal directly into the grid of the video amp, which eliminates all this stuff. The only thing left that could possibly be a problem with on this is the video amp itself. I would like to just inject a signal into this side, but the sync circuits are here. The sweep circuits are there, but the sweep circuits are here. There is that separate video cable, but that is just the cathode drive for the CRT. If I inject a video signal into that, there'll be no synchronization, and it'll just be a mess. So I'm doing the best I can and injecting to the grid of the video amp with the help of my TVA92, which lets me do positive or negative composite video up to 300 volts peak to peak. So It's a handy thing, because sometimes you need polarity positive or negative, and you don't know what the amplitude might be. So anyways, long story short, here's what we have. Problem's still there. And I'm driving this with a pretty hard signal to try to swamp out any noise, but we very clearly still have all that nasty interference. If I go with this test pattern, which is just a rectangle, it's all that. It's a weird sort of polka dotty kind of pattern. So one of the harsh bars we had earlier, that was with the shield off. Now the shield's in place, that's gone. But we have this nasty... It's curious. Oh yeah, I'm not feeding any audio in, so anyway. But there's a buzz. If I was going through the tuner, we'd be hearing a buzz as well. So, where's it coming from? I don't know. Sniff around for some ozone, don't hear anything. One thing I can try doing, it's the simplest thing I can think of, is I rebuilt that little pi filter on the high voltage. It's inside here. It doesn't seem all that much of a high voltage filter. There's a schematic. It's a couple 350 picofarad caps with a 100K resistor between them. I'm more accustomed to seeing a 4700 or 5000 picofarad filter cap, just a single filter cap on this. Not a total of less than 1000 with a little pi filter. So, we can, now this is inside the box, not easy to get at, but this point's very easy to get at. I'll tack on a 4700 picofarad high voltage cap. There's excessive hash in this. So here's the thing. I replaced this, let's see, what did I use? I used a couple of these guys, which are 560 picofarad. They're bigger than the ones that were in there. I figured that's got to be good. But these are Y5U dielectric. That's pretty lousy. The capacitance varies with applied voltage. It goes down. So maybe these aren't actually doing much in the way of filtering. So I'm going to try putting a plastic film cap on there, which do not suffer from that effect, and see what it has. Now the original I think was ceramic, but I don't know what kind of dielectric they might have used. Maybe they were mica. Alright, that made absolutely no difference. So, groovy. Now what? Well, now we can make use of an oscilloscope. It's not all that much that could cause a problem, and it really seems to just be in the horizontal plane, not the vertical. So it's either the modulating signal on the cathode, which we could actually eliminate. I could put a fixed DC bias on that cathode. But what I think the problem really lies is in the horizontal deflection signal, which should be a nice clean sawtooth. So let's check the signal on the horizontal amplifier and horizontal oscillator, which is this mess down in here. Well, there's the input to the horizontal amplifier. Doesn't look too bad. Let's check the output. There's one output. Doesn't look too bad. Remember, there's two outputs. We have two deflection plates to drive, and they are equal and opposite, or at least should be. So that's one plate of the 6SN7. Let's check the other plate. Basically, I'm looking at the two signals that are going to these two high voltage caps. I'm on the low voltage side. No, I don't want to accidentally destroy my scope. Now this one, the amplitude's a little bigger, but it's also looking a little fuzzy, isn't it? That doesn't look right to me. So I'm going to play around with it, see if I can zoom on that a little bit. Let's see, where is that coming from? Like I said, like an oscillation. So let's see. So I'm looking at pin 5. So the side that's directly driven. So I looked at the signal coming in, it looked pretty good. And this plate looks pretty good. It's this one, the phase inverted side, that looks bad. I've replaced that cap. I've replaced most or all of these resistors. There could be like a spurious oscillation going on inside there. A little hard to get at this guy. It's all really packed down tight in this corner. Well, let's do the obvious thing and just swap some tubes. This thing has 3 6SN7s in it. So I'll just play little musical chairs and see if that makes a difference. That's looking a whole lot better now, isn't it? Alright, so what did I do? Swapping out a couple 6SN7s made no difference. I wasn't really able to zoom in on the noise on the sawtooth that much, but I took a look at the power supply that's powering the plates, and it had noise on it. A couple volts peak to peak. I have my scope on the same point right now, and it's much, much, much less. It's hard to even see it. What are we down to? Half a volt. So what did I do? Well, 1, where's that noise coming from? And 2, what did I do to reduce it from 2 volts to 500 millivolts? Well, if you remember way back when we took an initial look at this set, there's something different about this than any other electrostatics that I've worked on. And that is, there's an extra tube inside that high voltage box, and there's some extra winding. That's why that coil is physically a lot larger than the ones I've seen in the past. That's because they threw in some extra windings and in a 6x5 rectifier tube to pull yet another voltage out of this. So in addition to the main power supply that powers the whole set, and the high voltage supply for the CRT, they derived yet another voltage. Think of it as B++. We have a little choke and a couple filter caps here, but they're tiny. They're just 0.01 microfarad. Filter choke, 0.01 microfarad, like a pi filter. It goes up and it feeds through 100K resistors the plates of this tube, and it goes to the size control, and that's it. That's all that power is used for. They needed a little bit more plate voltage on this tube than they could get from the other power supplies in the set. So what I did is I found this lead here, and I tacked on a 0.1 microfarad cap to ground. In other words, I added some additional filtering. That took care of the problem. So why isn't this sufficient? I don't know. I'm not inclined to tear apart the high voltage box again. Perhaps the choke might have a short in it, or there's a problem with these caps. I mean, I put in new caps. Regardless, that made a dramatic improvement. It looks, well, you can still see there's a little bit of a squiggle there. It's significantly less, but it is still there. The camera could even pick that up. So I'll try increasing it a little bit. Maybe put a 0.22, a 0.47, something like that on there. But then, hey, let's get back to fitting a video signal into this. I'm also curious to see is the audio improved as well. Throw a 0.47 in there. That's looking really good now. Let's try some other patterns. There's the circle. Yeah, wow. I think we got it licked. Much, much, much better. Much better. Loses sync occasionally. I still have this on its side on the workbench. I gotta, we seem to have licked this problem. I'll get this thing set back upright and go through and tweak the local oscillators. I was playing around with them earlier when I was trying to troubleshoot, and maybe touch up the sound alignment a little bit. We do have sound, but I think it could be a little better. A little too much buzzing in there. All right. I'm glad this is all it was. I thought this might be a lengthy troubleshooting process, but in the end, I just tacked these on. I'll clean this up, of course. Here's an extra high voltage filter I tacked in place. Is that turned on? I don't think we need this anymore. Just a little tweak on the sound ratio detector coil, and we are in business. So, time to turn my attention to the cabinet. Alright, back to the cabinet. The front face plate, while I had it out, has been cleaned up and polished. The cabinet, this is made out of plywood with a rather fragile coating on it. It looks like Tolex, the kind of stuff you use on a, say, a vintage guitar amp, but it's pretty thin. I think it's closer to wallpaper. So if you're working on a vintage radio or TV with this type of coating, be gentle. Don't use any harsh cleaners. A warm, damp rag, wipe it down, and then I'm using some VLR on it. This is all organic for vinyl, leather, rubber. It's waxes and oils, basically. It's like, think of it like doing the dashboard, like vinyl dashboard on your car. It'll help protect, preserve, and brighten this up a little bit, so I'm getting ready to do that over the whole cabinet. The leather handle's a bit deteriorated. I can use some of the same VLR on it, but it's a little too far gone for that. But it's still, the integrity is still there. And if you ever see a strap like this and you're worried that, oh, the leather's going to fail and you shouldn't carry it by this, there's a piece of steel inside. The leather's wrapping around a piece of steel. So it's still safe to lift by this. It's just the leather's deteriorating. Yes, there are companies that still make these today. If you didn't get the exact dimensions, it's probably a screw you can access from the underside. Then get the end of it off, the ends off, and replace this. If the owner really wants to, I can look into that, but for now I'm just going to leave it. Back's in great condition. I'll clean off a little dust here, and then we'll start putting this all back together. Not many sets have hinged backs. That's a novel feature there. Of course, I saved all the screws. I'll clean out the dust bunnies inside too. We'll be done pretty soon with this set.
I thought you might. H&I presents All Star Trek. 6 nights a week, starting at 8/7.
Set's working pretty darn well. I'm especially happy with the sound. Occasionally uses vertical sync, especially when we go from programming to commercials and back and forth. But generally speaking, this is one of the better 7-inch sets I've ever worked on. Alright, now let's take a final look at some cosmetic issues. So the cabinet, the VLR wasn't quite giving me the sheen I wanted, so I ended up going over it with Oz polish. These days VLR and Oz are my two go-to products for a variety of finishes. They're both all natural products and work really well, both on wood and Tolex type materials like this. Now, the last thing I'm fighting with a little bit here is the knobs. They're working well, but I've been trying to clean them. I've been able to polish up this surface pretty well, but the grooves are grungy, so I tried soaking them in dishwater using a toothbrush. But I'm resorting to, I put some Novus No. 2 polish on grooves and a toothpick, and yeah, the things we do. I tried using a brass wire brush on it briefly, but I'm worried about damaging the plastic. So, toothpick it is. I got one more left to do. And, That'll be that. Tedious, but it just looks terrible with all this crud and the grooves from years of dirt getting in there. Alright, tedious, but I think that's a lot better. Hey, it's got some wear, it's old. Alright, that is going to be it for the Sentinel 400. Alright, I think that's as good as it's going to get. Hey, this thing is from 1948 after all. Alright, that is going to be it. That is a wrap. Hope you enjoyed this Sentinel 400 TV project. The weird trapezoidal 7-inch electrostatic set from the late 40s. Weird design, okay performer, but well made. And certainly an eye-catching set to add to your collection. That's it for now. Thanks for watching.